And I'm going to present my study on channel selection guided by layer-wise relevance propagation for CNN-based EEG classification of major depressive disorder. Major depressive disorder is prevalent but can lead to suicide if not treated early. To enable objective and early diagnosis, EEG-based CAD systems have been developed. While deep learning improves diagnostic accuracy, its black box limits the clinical use. So we applied XAI method using layer-wise relevance propagation. This method works by backpropagating from the output to the input, calculating the relevance scores. These relevance values allow us to understand the model's decision, though the meaning of the positive and negative sign is still uncertain. We applied LRP-based channel selection to make CAE system more transparent and practical. Also, to determine the meaning of the sign, we used the 3 strategies for LRP-based channel selection. We recruited 40 male MDD patients and 41 male healthy controls. We pre-processed all eyes-closed EEG data with conventional method and segmented them in about 3 minutes. We used shallow convolutional neural network with live-on-out cross-validation and layer-wise relevance propagation for channel selection algorithm. This figure explains the algorithm for channel selection based on LRP. We divided the data into training, validation, and test sets. In the validation data, the relevance scores were averaged across time and classes, and the top N channels were selected based on each strategy. First, we use original relevance values, and the second, we use the absolute value, and the third, we set the negative values to 0 and sum up HC and MDD. When all EEG channels were used, high classification accuracy of 99% were achieved. With 10 channels across all strategies, the accuracy remained above 90%, and with 5 channels, however, the accuracy dropped up to around 75% across all strategies. These results indicate that the proposed channel selection algorithm can maintain strong diagnostic performance with as few as 10 channels. And this figure presents the frequency of selected EEG channels when channels were selected in 10. Across all strategies, the most frequently selected regions were concentrated in occipital, central, and prefrontal regions, which were related to the difference between MDD and HCs. In summary, the LRP-based channel selection maintained over 90% accuracy with an 84% channel reduction. The most relevant EEG regions were occipital, central, and prefrontal regions, which were related to the sensory, motor, and emotional processing in MDD. However, this study was limited by a relatively small and dominant sample. So for the future work, we plan to validate our algorithm with larger and more diverse sample and refine it. And moreover, we plan to develop the general model for both male and female to further improve the clinical use. Thank you for your attention.